Conservation of matter. Section 1. What are atoms? Matter is the stuff that exists in the universe. Nearly everything you can see and touch is made of matter, including you. Examples of things that are not matter are forms of energy, such as light and sound. Atoms are the smallest units of matter. Different atoms combine to make different substances. Atoms are too small to see with the naked eye or even with the highest powered standard microscopes. If approximately 50 million atoms of solid matter were lined up in a row, it would be only 1 centimeter long. Scientists use special techniques and microscopes, including scanning tunneling microscopes, to obtain images of atoms. Substances can be made up of one kind of atom or combinations of different kinds of atoms. An element is a substance that is made entirely from one type of atom. Examples of well-known elements include oxygen, iron, and gold. Elements cannot be broken down into simpler substances. The periodic table of the elements image shows all of the known elements. Each element is represented by its chemical symbol, which consists of 1 or 2 letters. The first letter of the symbol is always written in uppercase, and the second letter, if there is one, is always written in lowercase. For example, the symbol for iron is Fe. It stands for ferrum, which is the Latin word for iron. The periodic table of elements. Fe, iron. Section 2. Molecules and extended structures. Atoms can combine to form substances in 2 different ways. Some substances are made up of molecules. Molecules can either be made up of one type of atom or several types. A molecule that most of you are familiar with is water. As you can see in the diagram, a water molecule is made of 1 oxygen atom and 2 hydrogen atoms. Because atoms are so small, the bulk matter in everyday life consists of extremely large amounts of these building blocks. A glass of water, for instance, contains billions and billions of oxygen and hydrogen atoms that are combined to form water molecules. 1 water molecule. Oxygen atom, hydrogen atom, hydrogen atom. Stop and check. What are molecules made of? Some substances are not made of molecules. Their atoms link together to form large networks called extended structures. Table salt is made of atoms arranged into extended structures. Atom key. Chloride. Sodium. Crystals of sodium chloride. Chemical formulas are used to show the number and type of atoms that make up a substance. In a chemical formula, the atoms of elements in a substance are represented by their chemical symbols, and the ratio of different elements in a compound is represented by numbers written as subscripts. For example, each water molecule contains 1 oxygen atom and 2 hydrogen atoms. Therefore, the chemical formula for water is H2O. The subscript number 2 after the letter H shows that there are 2 atoms of hydrogen in a water molecule. The chemical symbol O for oxygen has no subscript because there is 1 atom of oxygen in a water molecule. When there is 1 atom of an element in a molecule, no subscript is used in the chemical formula. Stop and check. What is an extended structure? Section 3. What happens to atoms in chemical reactions? When you build a campfire like the one shown in the illustration, you start with a big pile of logs. As the fire burns, the pile of logs slowly shrinks. By the end of the evening, only a small pile of ashes remains. What happens to the atoms in the matter that you started with? Were they destroyed by the fire? Oxygen. carbon dioxide, and water vapor. Start, end. It may seem as though burning destroys matter. However, this is not the case. Before and after the fire, the same number of atoms exist. When wood burns, its atoms combine with oxygen and change to ashes, carbon dioxide, and water, vapor molecules. The gases float into the air and leave behind the solid ashes. This burning campfire example illustrates a very important law in science, the law of conservation of matter. This law states that during physical changes or chemical reactions, matter is not created or destroyed. This means that no atoms are created or destroyed during a physical change or a chemical reaction. The total number of atoms present before substances undergo a physical change or chemical reaction is equal to the total number of atoms present after the substances undergo a physical change or chemical reaction. Law of conservation of matter. In physical changes or chemical reactions, matter is not created or destroyed. The total number of atoms is the same before and after a physical change or a chemical reaction. The table that follows represents a reaction in which two substances, carbon and oxygen, combine to form a new substance, carbon dioxide. When you review the table, take a moment to count up the number of each type of atom to the left of the arrow. Compare that to the number of each type of atom that appears to the right of the arrow. Before combining substances. After combining substances. Carbon plus oxygen yields carbon dioxide. C plus O2 yields CO2. One carbon atom plus two oxygen atoms yields one carbon atom and two oxygen atoms. Notice that all of the atoms that were present before the reaction, to the left of the arrow, are also present after the reaction, to the right of the arrow. This demonstrates that no atoms were created or destroyed in this chemical reaction. All the atoms present before the reaction are still present after the reaction occurs. The chemical reaction resulted in a change in the arrangement of the atoms, but no atoms were created or destroyed. Stop and check. In a chemical reaction, can atoms disappear or be destroyed? Explain your answer.